So as we start 10-5 today, just to review our game plan for the week, Chapter 9 Mastery will be Wednesday, but then Thursday we'll finish that one if we need, and then we will start the Chapter 10 Mastery. So we're going to take 2 Masteries this week, because we kind of got behind waiting, because I have that sub day on Wednesday. So I'm going to be gone on Wednesday. You guys will start the Chapter 9 Mastery. I'll come back on Thursday, take any questions that I need to help you with, and then we'll just go right into the Chapter 10 Mastery. So if you get done with Chapter 9 on Wednesday, you'll just need a book or something to do, but if you finish it then on Thursday, when you turn it in, I'll just hand you a Chapter 10 Mastery, assuming that your homework is done. So, Perry the Pelican's back.
Okay, I get the hint. I gotta cut back on snacking between meals.
Now, Perry the Pelican, like myself, has put on a few pounds. So, when he sat down on that line, he moved figure 2. What do we know about figure 1 compared to figure 2? What's their differences now? Cassie?
Figure 1 has right angles.
Figure 1 is composed of all right angles because I know that my lines are straight, and if one angle, angle 1, is right, then they all have to be. What kind of intersection is that? Those lines make what relationship? They are perpendicular because they make 90-degree angles. So then, what's different about figure 2? Bella?
It's because of acute and obtuse angles.
So now I've got acute and obtuse angles. What angles are acute here?
1 and 3.
1 and 3 are acute because they both got smaller when Perry sat on that. 2 and 4 both got bigger. What could we still say about angle 1 and 3 and angle 2 and 4 though? Yeah, but more specifically. Thomas, you got a guess?
What? Wait.
I asked, do you have a guess?
Okay, I have a guess, and I think that angles 2 and 4 are 100 each on both sides.
How do you know?
Because if angle 1 is 80,
You show her figure 2 and tell her that angle 1 is 80 degrees. I don't know why the lines are next to it. I think that's kind of a glitch with the system today. So if angle 1, if I get told that this is 80 degrees, that means that my ray moved this way, but also that means that at the bottom my line moved this way. So, like Thomas said, which angle were you saying is 100?
2 and 4.
So
And
this would be 100. How do you know that angle 2 has to be 100? What relationship
Because
do 1 and 2 have?
80 lost 10 degrees.
I
That means
agree.
angle 2
But
gained 10 degrees.
before we start talking about which has, like, what gains and what gives, what relationship do 1 and 2 have? No matter what happens to this line, no matter what I do to it, angles 1 and angle 2 have to be, Isaiah. Not 1 and 2. 1 and 2 are right beside each other. They're adjacent, but more than that,
Oh, supplementary.
they're a supplementary pair. So no matter what happens to my line that goes through here, my transversal is what that line is called, angle 1 and angle 2 have to add up to 180. Now what about angle 1 and angle 4 down here? What about angle 1 and angle 4? They're both supplementary. So angle 4 would have to be the same. So now what we see is angle 1 is equal to angle 4. Sorry, not 4.
3 and 3.
Angle 1 is equal to angle 3. And likewise, angle 2 is equal to angle 4. Because of the supplementary pairs, we can see that we have those 2 sets of equal angles now. Now this actually leads me, this is like the proof of making vertical angle pairs. Vertical angle pairs have to share the same vertex, which angle 1, 2, 3, and 4 all have the same vertex here, and then the same 2 lines that make up the angles. Now look here, I only have this line, my blue line, and this line, my red line. So angles 1 and 2 actually both use the same lines and the same vertex. So do 1 and 3, so do 1 and 4. The other thing that makes vertical angles vertical is they cannot be adjacent.
What?
They cannot be adjacent. They cannot be right next to each other. So when I look at angle 1 here, and I want another angle that shares the same vertex and the same two sides, it's got to be angle 3. Because angle 2 and angle 4 would both be adjacent. Can't use them. Got to be angle 3. And then we see that those are equal. Questions, comments, or concerns at this point? Rihanna?
Do they have to share a vertex?
They have to share the vertex, yep.
And both?
So, what you need to fill in on your paper where the blank is, vertical angles have equal measures, or you can just say are equal, are the same, are equivalent, if you want to sound real fancy. So what we really have up here is just two lines. They intersect and form two sets of vertical angles. So if you have colors, here's where I would suggest using colors. Angles 1 and angles 3 are vertical because they share the same vertex. They're made up of the same two lines and they have equal measures. And angles 4 and angle 2 are vertical. They share the vertex, share the same two sides, and have equal measures. Now, being vertical makes them have equal measures. So, being vertical makes them have equal measures. Once we identify they are vertical, we know that they're equal. There's no question in my mind. Any questions? After I just said there are no questions? I bet we can pretty efficiently solve some problems with these. So I'm going to go to cards. When we look at our spider web here,
Hey Pete, feel like going for a spin?
Absolutely. I'll race you.
Wow, Pete, you took a tough angle on that last lap.
I know. I'm almost completely spun out.
yeah, I know, they just keep cycling the same noises. All right, so here on your notes page, a little easier to see. I want angle pairs that are vertical, and we've only got a few angles listed here. So check it out, try it on your paper, write down what you think. You can always erase or cross it out if you make a mistake. Question?
No, I haven't.
I'm going cards. Sorry. Remember, they have to share the same vertex, the same two lines that make up both angles, and they've got to be equal. Brennan, what do you think? 7 and 8. Let's check these guys out. 7 is made up of this line and that line. And I can see so is 8. 8's made up of the exact same two lines. They share the same vertex. They're opposite each other and equal. 7 and 8 works. And if you want, you could put the angle symbol. Ethan, is there anything else?
Oh, 5 and 6.
5 and 6, if I look at the lines that 6 uses, it's that line and this line. 5 uses the same lines. They are opposite and equal, so they work. Why won't angles 1 and 2 work? Isaiah, do you know why won't angles 1 and 2 work? So if we, Eli? They're what?
They won't add up to.
It's not about what they add up to, but they need to be equal. I agree they're not going to be equal. Here's why they won't work. 1 uses this line, and that line stops. it does not continue through the vertex. And then angle 1 uses this line. So one of the sides is shared, but this side on angle 2 is not shared with angle 1. And that's not even what uses angle 2. It's this side for angle 2, and that has nowhere to go except straight through angle 1. Can't work. Same thing with 3 and 4. They share this side, but if I look at angle 3's other side, it comes right in here, and it's got nowhere to go. It is not the same side that angle 4 uses. Oriana?
I have another one. I
Okay.
don't think anyone's seen 4 and 8.
They'd have to share the same vertex. So right away they can't be.
Don't they? Like if you
4 and 8?
Why do you do it?
So 4's vertex is right here. 8's vertex is right here.
Okay.
Yeah, so that rules it out almost immediately.
Well, I thought it was like in the center. So then, go like that.
All right. A, B, C. First, I want you to draw the little arc to notate where A, B, C actually is. Where A, B, C actually is. Then, I want you to trace both sides of ABC and continue through the vertex. So here's what I mean. Step 1, draw your arc. Here's angle ABC. So now step 2 is going to be drawing my shade on my lines. I'm going to start at A, go to the vertex, and just keep going through the vertex. So I get that side. I do the same thing for the other side, starting at C. I just go through the vertex. And now the 2 rays that I have shaded are going to make up the other angle that I want to use. So the angle that is vertical to ABC is what angle? RBW. So angle RBW is vertical to angle ABC. Questions on how we figured that one out? Start on the angle that you're given, go through the vertex to find that other angle. Now here's a question that's a stumper for a lot of people. Can vertical angles also be supplementary?
Yes.
So let's think about what it takes to be supplementary. What do we know about supplementary pairs? Brian? They equal 180. Remember, you take supplements to get bigger. Thomas?
And they don't have to be adjacent.
They don't have to be adjacent. Can they be adjacent?
Yes, they can.
Yeah, they can be adjacent or not adjacent. Can they share the same vertex?
Yeah.
Can they not?
No.
Yeah, they cannot share the same vertex.
Yeah,
they can have 2 different vertexes.
Yeah, they don't have to.
Yeah, they don't have to have the same vertex. So I want you to draw how 2 angles would be vertical and supplementary, drawing arcs in those angles. Or you can draw a different symbol, but I'm not going to give it away yet. How should I draw my other line? Oriana? Huh?
Never mind.
Brandon? What angle do I want to create? A right angle. So when I draw my other line, I want to make it perpendicular. And then I'm going to label 2 opposite angles. So I'm either going to label this angle and this angle to be vertical and supplementary, or this angle and this angle could be vertical and supplementary. But I could only use the green pair or the blue pair, because remember, they have to be opposite from each other. Vertical angles cannot be adjacent. So if I label these angles 1, 2, 3, and 4, I have angles 1 and 3 are vertical and supplementary, and angles 2 and 4 are vertical and supplementary. Any questions on that? Could two vertical angles be complementary?
No.
What would they have to be?
They both have to be half of 90.
They would both have to be half of 90. So they'd both have to be 45, right? So I could actually take my image here and make two vertical complementary angles by bisecting and making two 45 degrees. Here's all I would have to do. Label this like this angle and this angle. Notice they both share the horizontal black, they both share the red, and both of these could be 45. Those would be vertical complementary pairs. They'd both be 45 degrees. Questions? Cool. Oh no. Well, if they watch the video, they'll understand. So this might be a little hard to see on your paper, but we are on the back now. Actually, it printed a little nicer. If I know that my 140 degrees is this side of the skis, and I know my 4x plus 40 is this side of the skis, how can I solve for the value of x? How can I solve? Eminal, what do you think? How can I solve for the value of x? Yeah, we see that they're vertical, so we just set them equal. So we say 4x plus 40 equals 140. Then we subtract 40 from both sides. We get 4x equals 100. I'm going to show my work. Then we divide it by 4. X is 25. Questions, comments, concerns? All right, try the got it on your own. There's a couple different ways that you can solve this. I will caution you, if you look at 40 and 5x, 40 uses this side and 5x does not. So 40 and 5x are not vertical. They are not vertical. So what you need to figure out is if I want to use 5x, what is 5x vertical to? Well, if we think about the sides of 5x, I've got this side right here. I can continue through the vertex. And I've got this side right here. I can continue through the vertex. So I find that this angle is actually the angle vertical to 5x. Bela, what is going to be the size of that angle that I just drew? Sorry, I can't hear you. Okay. 90 is the entire angle right here, but where I drew with my little blue arc is not the entire 90, it's only part of it. Crystal? Do you know it? Ah, you're close. Bella? How'd you figure out that that's 50?
Because 50 plus 4 equals 90.
We know that this angle right here is 40. And if I know that the total of the two of them makes a 90, then I know that that angle has to be 50. Pay attention that the angle we're labeling is UYH. It's just this small angle here. So then we can say 50 equals 5x. And what will x equal? 10. Questions? You first had to identify the complementary pair that was there. We started with the complementary pair. Are we still feeling good about this?
Yeah.
Your friend claims that vertical angles could be acute, right, or obtuse. Now we've already proven right. We saw that they were supplementary.
And acute, because the last one, 5x, that's also acute.
So we already proved acute. Now if we wanted obtuse vertical angles, again, I can always start by just drawing a line. So if I start by drawing a line, now my second line that I draw is going to have to intersect, but I need to make an obtuse angle, which the funny thing about when I make an obtuse angle is I also make an acute angle. So if I just draw another line, as long as it's not perpendicular, I've made a cute bitty angle and a big old obtuse angle. And that big old obtuse angle, I'm actually going to change colors here. Does it have an angle vertical to it?
Yeah.
You bet it does. Whatever shares the same vertex and the same two sides. So this angle would be obtuse. But what I also see here is I've created a pair of acute vertical angles also. So my red angle equals my red angle, and my green angle equals my green angle. We have vertical angles can be any size. So that's the big thing that this is trying to reiterate, is vertical angles can be any, well, we normally don't go past 180. We're like how we are starting, we normally don't go past 180. You will eventually, but we don't normally, because anything past that and you can't really be vertical. So I guess I will rephrase that. Vertical angles for us will be less than 180. You won't ever have to work with angles bigger than 180. Questions? All right, one last problem to see if you really understand this then. Looking at the figure to the left, figure out what the measures of angles A, B, and F are. So I want you on your paper to be able to write measure. Remember the M out front means measure of angle A equals. We'll do measure of angle B equals, and measure of angles F. Angle A. Crystal, we just talked. We've talked a lot. Layla, what do you think about angle A? Why does it equal 70 degrees? A, exactly as Layla is saying, is vertical to your 70 degrees. It uses the same two sides because A uses that side and this side, and so does that 70-degree angle. So they must be equal since they're opposite. Now angle B, this angle right here. Karina, do you know how to solve for angle B?
Since 70 and 70 is 140, and to get 180, wouldn't you do 180 minus 140, which is 20?
Not minus the 140. So what you're looking for, the supplementary pair, Bella?
Well, I was going to say that 70 is 20 less than 90, so wouldn't you add 20 more than 90?
Yeah, so you're thinking that we started vertical and we like went 20 degrees, so I like that thought process.
But it opens up 20 more degrees on the
Right,
side,
yeah.
So it would be 110. Or, yeah, 110.
So here's really what we want to look at. I love Bella's thought process, but not everyone's brain works like that. We see that this is supplementary. If I start from a line and end up on the same line, that's going to be a supplementary. So angle A and angle B have to add up to 180. Angle A, we just said, was 70. So angle B has to be its supplement, which is going to be 110. So B has to be 110 degrees. And then, Bunger, what are you trying to say? F must be the same because they are a vertical pair. Questions, comments, concerns on any of this? No. Wonderful. if somebody could be so kind as to pass out the next set of notes, we will then get through as far as we can on that lesson. I will reset the video so we have separate videos.